Alright guys, we're going to talk about a separate kind of sequence today. We're going to talk about geometric sequences, which simply means an ordered list of terms or ordered list of numbers which have a common ratio. Okay, it means they're multiplying by something. Some R value. So, if we had 7, 14, 28, 56, we'd have a ratio of 2. And you can find that ratio anywhere along the line by dividing by the previous term. Okay? Anywhere. Now, we could have a list of numbers like 12, -6, 3, -3 halves, where -6 over 12 is -1 half. 3 over -6 is -1 half. Okay, so R is -1 half. Now R can also be a decimal, etc. Sometimes it's harder to identify R and you might need your calculator, and we will do some of those in a second. Alright, so the explicit form, again, means based on the term number n, and it goes like this. You take the first term times R and you multiply. So if you multiply by R again and again and again, that's an exponent. Whoops. So, but remember, for the first term, you didn't have to multiply by R. So what happens is every time after that, you multiply by R. Okay, so it's the first term multiplied by R, and then it's the term number minus 1 here as the exponent. Okay, so that's the explicit form. And be careful, you cannot multiply these two numbers together. Everybody get that? You cannot simplify. Just like when we did the log chapter, if we had 2 times 3 to the n, that does not equal 6 to the n. Do not do any crazy business. Okay? Alright, the recursive form means based on the previous term. And just for the vocab, a sub n is the nth term. A sub 1 means the first term. I should have written this earlier, but a sub n minus 1 is simply the term before n, so I always just word it as the previous term to a sub n. So we say any term is based on the previous term times whatever R is, and then you have to tell me what term to start with. That's what it looks like to write a recursive formula for a geometric sequence. So, if the sequence is geometric, there's a common ratio. So, on this one, you could take 8 divided by -16, -4 divided by 8, 2 divided by -4. Every time the ratio is -1 half. Okay? So they kept multiplying by -1 half. So it is geometric. On this one, it's much harder to see you could say negative 10 divided by negative 20 is a positive 1/2. So here they multiplied by 1/2. But it's pretty obvious to me they did not multiply by 1/2 here or here. Okay, so this is not working. If you had tried negative 20/3 divided by negative 10, you would have gotten 2/3, I believe, times 1 over negative 10, yes. If you had tried negative 5 divided by negative 20/3, this would have flipped over. You'd have had negative 5 times 3 over negative 20. This would go in here 4 times. You'd have had 3/4. So R is not the same. It kept changing. Okay? All right. I wasted time doing that. But, okay, find the common ratio. This time they're telling us it is geometric. So we're supposed to find the ratio and the next 3 terms. Okay. Maybe I'll just do this one. 4/3 divided by 2 should give us R, or 8/9 divided by 4/3 should also give us R. Now you could use your calculator. I'm just going to quick flip this guy over and whoops, yeah, 8 goes in there. Okay, I get 2/3. Let's see. 2 times 2/3 would be 4/3. And times 2/3 again would be 8/9. Okay, that seems to be working. So I got R is 2/3. I'm thinking here R is just negative 4. And then you guys could finish that one. But over here, we got to find the next 3 terms. So 16 times 2 would be 32. 27 times 3 would be 81. Calculator would come in handy now. We get 64 and 243. Double that, we get 128, and multiply that by 3. I think we get 729. Okay? So leave things in fractions so that they are exact. Okay? Don't round to decimals if you aren't given decimals. Given the explicit formula, so this time we have a sub n equals a sub 1 times r to the n minus 1. So we can identify a sub 1 is 2 and r is 6. Or we could have found that by putting in a 1. Okay, a sub 1 would be 2 times 6 to the 0, which would be 2. A sub 2 would be 2 times 6 to the 2 minus 1. A sub 3 would be 2 times 6 to the 3 minus 1, which would be 2. Okay? So find the first 4 terms. We have 2, 12, 72, and then if we multiply by 6 again, we get 432. And find the common ratio. The ratio was 6. All right, I guess I'll do this one. I should have left the last one for you. But so the first term here, and if this didn't say n minus 1, this would not be the first term, and we'd have to figure it out by putting things in. So maybe we should do it that way. But so on your calculator, you could just type negative 0.25 times negative 4 to the 1 minus 1, and you should get negative 0.25. And then if you do negative 0.25 times negative 4 to the 2 minus 1, I believe you'll get 1. Negative 0.25 times quantity negative 4 with the negative inside to the 1. Okay. And then negative 0.25 times negative 4 to the, we're on the third term, so 3 minus 1 is 2. should be 16 times negative 1/4 would be negative 4. And if you want to keep going this way, negative 64 times negative 1/4 would be positive 16. R is simply negative 4, where the first term was negative 0.25. Oh, we're supposed to find the next 4 terms? Oh, the first 4 terms. Okay, I'm doing it right. 1, negative 4, 16. Whenever you have a ratio that's negative, every other term should change sign. Okay? All right, given the recursive formula, find the common ratio and the first 4 terms. Okay, they tell us the first term is 108, and then they tell us to multiply by 1/6. So 108 times 1 divided by 6 is 18. 18 times 1 divided by 6 is 3. 3 times 1 divided by 6 would reduce to 1/2 or 0.5. I really don't care. That's the first 4 terms, and the ratio was 1/6. All right. Find the common ratio in the 8th term. Okay, here they are multiplying by negative 4. Or you could do 8 divided by negative 2 equals R, or 128 divided by negative 32, anywhere along the way. But let's use the explicit formula to find the 8th term. You take the first term times the ratio 8 minus 1 times. So we'd have negative 2 times negative 4 to the 7th to get the 8th term. Now, I just use lots of parentheses. You actually don't need the first set, but you do need the second set, at least if it's a even power you do. On this one, you get 30, positive 32,768 for the 8th term. Where's my key to this? Make sure I don't make any mistakes here. All right. Find the explicit term. Well, the explicit term looks like this. And we get to leave the n in there. So we just need to put in the first term. And we need to figure out what the ratio is. This guy's just multiplying by 5. So we have a sub 1 is 2 times 5 to the n minus 1. You can leave it like that. I'm just really worried that someone will do something silly, so I always put r in parentheses. Because you can't do 2 times 5 is 10 because of the exponent. I should let you do this one, but I will do it real quick. The first term, they're multiplying by 1/3 because r is 1 before the, so you have 1/3 divided by 1, 1/9 divided by 1/3, okay? Anywhere along the line there you can do r. So it's 1/3 to the n minus 1, okay? This is not the same as 3 times 1/3 is 1 to the n minus 1. If you did that, you'd just get 1, 1, 1, 1, 1. Okay, that's not what this is. So you cannot simplify. All right, find the recursive. Well, we got to find what r is. Let's see, 4 over negative 8 makes r negative 1/2. And the recursive, remember, is the previous term times what? And the first term is something. So here you could say the first term is negative 8, and every term after that is the previous term times negative 1/2. Okay? A lot of times they would write it as a multiplication, and they would say the first term at the end. Doesn't matter. All right, I'm going to let you do 15 because that looks pretty easy. Given the recursive formula, find the explicit. Okay, so this is just telling us r is 1/2 and the first term is 16. So the explicit would be 16. Let me write it up here. That's explicit. So 16 times 1/2 to the n minus 1. So this one would be 2 times, there's r, negative 5 to the n minus 1. That's it. All right, find the recursive. Well, we really already know a bunch of things, but just in case there was not an n minus 1 up here, to find the first term, we could put in a 1. So 0.4 times negative 5 to the 1 minus 1 would be 0.4 times negative 5 to the 0. Anything to the 0 is 1, so we just got 0.4 is the first term. It's supposed to be a decimal point. And then to find the second term, 0.4 times negative 5 to the 2 minus 1 would be 0.4, this would be 1 time, and I think that's 1. 0.4 times negative 5 once is negative 2, sorry. So if we were listing the terms, we have 0.4 is the first term, negative 2 is the next term. Okay, if we put a 3 in here, 0.4 parenthesis negative 5 to the power of 3 minus 1, you get 10. So sometimes it helps to generate some terms, but the recursive formula just means you have to tell me the first term and then how to get to the next term. Well, to get to the next term, you take the previous one and you multiply by, what are they multiplying by here, guys? Negative 5, right? Okay, so on this one, this is a sub 1 and this is r, basically, because it's written so nicely. But if you weren't sure, you would put in n equals 1. That would make this to the 0 power, which would make this 1, so you'd get 4. And you'd say every time after that, they are multiplying the previous term by, and it turns out to be 1/5. I'm going to erase that because that looks kind of funky sitting there. Okay, again, you could put in a 1, you would get out a 4. If you put in a 2, you would get out a 4/5. If you put in a 3, you'd get out a 4/25. Okay, so you could generate the terms and then see what's happening. All right, find the 11th term and the explicit formula. So this would be easier to do first. Explicit formula is this one. So a sub 1 is 3/2. R is, what are they multiplying by? Well, the top, they're multiplying by 1. The bottom, they're multiplying by 2. Or you could do 3/4 divided by 3/2, and you would get 1/2, okay, when you type that in your calculator correctly. Which would need some parentheses. All right, so they're multiplying by 1/2. So explicit formula is 3/2 times 1/2 to the n minus 1. The first parentheses actually aren't necessary. The second parentheses are. And then it wants the 11th term. So we're going to do 3/2 times 1/2, 11 minus 1 times. And you want an exact value. So you should go ahead and change it back to a fraction. Some of you would be doing this the shorter way, but I'm going to do it this way. And I already forgot what it was. 11 minus 1, we want the 10th term. Math, enter, enter, is 3/2048. Now, another form, explicit form of this would actually be 3 over 2 to the, let's see, 2 times 2 to the n minus 1 would be 2 to the n, I think. So let's try, I'm just trying to simplify this and show you that explicit doesn't always give you an n minus 1 in it. If I wanted the 11th term, 3 divided by 2 to the 11th, okay, this is actually equivalent to this. Okay, you don't have to know that, but explicit form does not always mean they wrote it nicely how we want it. Explicit just means based on the term number. Did I skip one? So here, if I do this one with you real quick, a sub 1 is negative 1.5. So our explicit formula would have a negative 1.5 times, appears that r is just negative 2, right? So there's the explicit formula, and you cannot multiply those together and get rid of the negatives or anything crazy. So to find the 11th term, you'd have negative 1.5 times negative 2 to the 11 minus 1, or 10 times. You got to type that carefully because it's actually going to be a negative 1.5 times, and when you do negative 2, you can put that in parentheses, it wouldn't matter. Whoops. But when you do negative 2 to the power of 10, that's going to become positive because it's an even exponent. And then when you multiply by a negative, you're going to get a negative answer. Is that what that number was? I already forgot. Yeah. Okay. All right. Is this the last section? Maybe? Oh, but there's a lot of questions. Is there some I can skip? I don't know. I'll do them. All right. So when you have two terms in a geometric sequence, again, this was something, negative 2, term 3, term 4, term 5, and then, whoops, term 5 is 16, sorry. So what you have to say to solve this is from here to here, there were 3 r's multiplied on there. You subtract those two numbers and you get 3, because this would be 1, 2, 3 times they multiplied r. And when you multiply over and over and over, it's an exponent. So then if you divide, and then remember, it's okay to cube root a negative number. You just get a negative number. Now, remember the cubed root is equivalent to the power of 1/3. So it would have been faster, in my opinion, to type negative 8 to the 1/3 power than it would have been to go in here and find this cube root thing, which is here. But either one will work. But we will have some where you have like the 4th root or the 5th root. And when you have that, you can do to the 1/4 or the 1/5 power. All right. So we just found r. What else are we supposed to find? Explicit formula, and then find the 10th term. Oh, we got to be a little bit tricky here. So we just, if this is the 2nd term and we're multiplying by negative 2, the next term would be 4 times negative 2. But go backwards, if we divide by negative 2, we get 1. Okay? So you have the first term times r, n minus 1 times, became, let's say, the 2nd term. So n would be 2. So you'd have the first term times r became the second term. So r, or if you wanted the first term here, you'd have the second term divided by r, give you the first term. That's crazy business. You guys can just logic this out. I know you can. All right. So this formula is a sub n equals 1, which was the first term, so actually you could leave that off, negative 2 to the n minus 1, and they want the 10th term, so you'd have 1 times negative 2 to the 10 minus 1, or 9th, and negative 2 to the 9th power is negative 512. All right. This one looks like it has, oh no, it's not. I thought it was, they have them in a funky order. So there's term 1, term 2, term 3, term 4, term 5, term 6. So between terms 3 and 6, there are 3 r's multiplied to become term 6. So multiply by r, r, and r. So if I divide 1024 divided by 16 is 64. 64 to the 1/3 power is r, which is 4. So if r is 4, I can work backwards. I could go forward here, times 4 times 4. I think that's right. Divide by 4. Divide by 4. Wow, I got 1 again. So the formula is the first term times r, n minus 1 times. So the 10th term is 4 to the 10 minus 1, or 9, is 2, 6, 2, 1, 4, 4. All right, let's see. This one gives you the first term. Maybe I should still do it. Okay, it says 4 because then it goes term 2, 3, 4, 5, 6. Term is 128. So what happens is they multiplied by r 5 times. Whoops. 128. I don't know where I got that number. Oh my goodness. So if we divide here, divide by 4, and I get 32. So then I need to do either the 5th root of 32 or 32 to the 1/5 power, and I get 2. So r is 2, and they already gave us the first term, so you could fill all those in, but basically it's 4 times 2 to the n minus 1 is the explicit formula, and they wanted us to find the 9th term. So you'd have 4 times 2, 9 minus 1, or 8 times. 4 times 2 to the 8th power is 1024. All right, last one. This one is actually sweet because it gives us 2 terms in a row. So we had something, something, 9, 27. So I can tell right away that r was 3, because we could just put those over each other. And we've got to go backwards and find the first term. So if we divide by 3, we get 3. We divide by 3 again, we get 1. Really? So the first term is 1, r is 3, so a sub n equals 1 times 3 to the n minus 1. To find the 11th term, we'd have 1 times 3 to the 10th, which is 5949. 59049. I don't know what I said. Okay, so those are the notes, and examples on geometric. Now do the practice.